So, I'm here to talk about how open source created a bunch of problems for us, basically. And furthermore, not just through the proliferation of software, but because of the patterns and they spawned a tech industry that give us new software development patterns that we'll talk about a lot today, how that in itself have created issues for us, and not surprisingly, how fundamentally the solution is also something that's going to require open source. So, a little about me. I've been working in open source since approximately 1999, before it was called that. I've got a career educating developers one way or another. More recently, I had the privilege of spending a bunch of time at Google helping open source projects grow, particularly with regard to their strategy, their community. So big projects like TensorFlow or Go or Kubernetes were things that my team looked after. So I've seen open source from a business perspective, from an ecosystem perspective. And now I'm hanging out at a company called Sysdig, and we work in security, particularly runtime threat detection. We're with contributors and the creators of Falco, which is an open source project homed at the CNCF that does runtime threat detection for hosts and containers. So that kind of informs a little bit of my perspective today, and I've certainly brought some facts and figures from that world to share with you. So I'm super grateful for being invited. You know, my chief claim to fame is that I've seen a few technology waves come in and out and still have a job. You know, you are all deep experts, and other speakers are deep experts in their field. But perhaps what I can offer, you know, despite open source and security being very intricate and detailed, broad topics in themselves, is that, you know, it's all often just as much about people and the social constructs and the social agreements that we have as it is about the technology. So I'd like you, those of you who can join with me, to come back in history a little. Cast your mind back to the late 90s, if you will, where we were starting to use free software. The term open source hadn't even been coined back then. We had FreeBSD, NetBSD, we had the emergence of Linux, and we were really smug because Windows had all these problems and we didn't, partially because no one was really using Linux to be a useful attack surface. But we were, you know, feeling pretty happy. What passed for security back in those days was closing a port. You know, we would use Telnet to get from machine to machine, and they were, you know, this was the before times. Windows is the big target, and we felt ultimately that SSL was a big innovation at the time. And so we were using open source operating systems, distributions, and that's how we were fundamentally getting our security patched. That was security, keeping your distros up to date. And it's very interesting. I want to bring in my first figure here. Still, it turns out that operating systems, distributions are the safest base for operating in. This is a figure from a 2023 report that I'll cite a bit during my presentation. This shows on this chart where vulnerabilities occur in the workloads we've been able to observe through our customer base, largely a lot of Kubernetes workloads. And we can see that only 3% of high vulnerabilities are due to the operating system. If you want to contrast, if you look at vulnerabilities that accrue from things like packages, like from PyPI and so on, they're more like 52%. We have high criticality vulnerabilities unpatched in the wild. So still we see that operating systems are, you know, a fundamentally good bet for where we get our base of patched vulnerabilities. However, I'm not here to talk about where we were, but kind of where we're going and what happened from this point onwards. So the thing that happened was we started sharing software in ways other than operating system distributions. Let me tell you my own story here about how I created a vulnerability that went into the wild. And I can talk about it happily now, but it was pretty embarrassing at the time. The emojis haven't come through, but you can imagine embarrassed faces in the bottom left here on this slide. So my very first piece of open source that I released back in 1999 was an XML RPC layer for basically providing web services to PHP applications. And because I like writing, I documented this really rather well. And it turns out that good documentation is a very strong indicator for software that will get popular. And it got a lot of uptake. And the library was imported, not by me, but by somebody else into a system called Pair, which is a package management or package library for PHP. And from there, it went into some software you may have heard of, WordPress, Drupal. It kind of got all around the web as the API layer for content management systems and a few other places. And in 1995, a remote evaluation exploit, in 2005 rather, a remote execution exploit was uncovered. And this guy, I was 25, I had no business writing software that would go worldwide into people's web applications, but that's what happened. And the CV happened and an awful lot of software was exposed for a while, and we got it fixed. But I was just a guy, I was young, I had no idea what I was doing. And this basically is the underlying story of a lot of the open source proliferation that created the sort of network of vulnerabilities that we have today. So we're really talking about this problem of securing the software supply chain. In the last 20 years, software development has changed pretty significantly. Open source has now become an important part of our computing fabric. But it's not just the adoption that has changed. We've also seen that the social contract between creator and consumer has changed. When I first wrote open source, I thought the license was it. I was mostly worried about getting sued for defects. And so, the caveats in your open source licenses were the things I concentrated on then. And perhaps naively, I thought putting the license file was the beginning and end of it. But we've seen, the way these things work change quite significantly. GitHub and Node, NPM in particular, have created a sort of a permissionless web of software adoption that was quite unlike what was happening before, where we were releasing things and they're going into distros that were checked by people. So we have a permissionless web of trust where, frankly, the trust isn't merited, but naively, we take a lot of it on. I'm personally, deeply uncomfortable with some of the social conventions and assumptions and the obligations on free and open source software authors that tools like GitHub and their default manner of use have set up around open source. However, this is the world we live in, and no amount of me being uncomfortable is going to wind back the clock on this. So I want to show you just a picture of some of the effects of this new normal. There's a great site called deps.dev that Google released, which shows dependencies between packages and package management systems. We're here to talk a lot about cloud and multi-cloud, and Kubernetes is very important to that. Kubernetes has 231 little packages making up its dependency network. If my friends at Tetrate won't be offended, you'll note that Istio has 241. So there are an awful lot of teacups, as it were, stacked, an awful lot of things in the dependency chain for modern software. And so there's no question that open source has won in the enterprise as well. I was poking a little fun at Windows before, but frankly, one of the exciting things about Windows today is that it ships Linux inside it. There's a full operating system there. And very little server-side development use proprietary tools. The data in this chart shows the open source tools that the Sysdig report found running in containers. And you can see there's a huge footprint here for things like Go packages and the JVM. This survey was actually based on containers, and admittedly, container adoption is probably only about 30% of the cloud right now, but it's pretty significant. This may be oriented a little more towards the front runners, but also the scalers as well. And of course, all new programming languages today come out in open source. It's unthinkable that you would try and create something for a broad audience that folks had to pay for. Interestingly, some ecosystems have it worse. Not every programming system and language is equal in the way that the vulnerabilities make it into runtime. You can see that though Java makes up only 24% of the runtime packages that we found, the number of vulnerabilities it actually exposes at runtime make up 61%. And despite my many deep misgivings about the proliferation of JavaScript and Node and so on, you can see that although there are many packages involved, the number of vulnerabilities are quite small. Just to again underline the Java thing, most of us were probably had to deal to some degree with the log4j vulnerabilities a year or so ago. And the impact of this was huge. If you look up on deps.dev, the impact of this, log4j impacted 13,600 other software packages, approximately. So this, by the way, is also why runtime security, not just knowing what goes into your systems, but what's actually running in real time in production is very important. Because you could see, for instance, if you take JavaScript as an example, you could look at the number of packages and the number of CVEs that come in for it and be overwhelmed. But if you understand that 1% that's actually exposed, you can cut down that risk and prioritize what you address. So that's a hint towards the fact that we need something that is holistic. We need a solution that covers from the very beginning of software to the very end and has a feedback loop in it. The other thing I mentioned was that open source software has spawned new ways of computing altogether, thanks to what the clouds, the hyperscalers have had to do to make their systems work. And that's part of why we're here today, to discuss that. So the most important, I think, of these are containers and they are Kubernetes, and along with it, the new working practices that have come along. So, among the impacts, we see the rise of continuous CI, CD, and rapid release. It turns out that among containers, about 2/3 of container images tend to be replaced within 2 weeks. So this is good, and this is bad for security. But what is inescapable is that the security practices need to be updated to keep pace with what this new reality is. We also see that many, many images are actually pulled into production from public registries, kind of assuming that trust with the package registries. In fact, at the point in time the survey was taken, 56% of images in production were pulled from public registries, though this number is actually slowly declining. Along with Kubernetes comes microservice-based design, service meshes. They bring another layer of complexity, and they're very difficult right now where we are to debug and to audit. So it's our practices as well that are introducing risk. And finally, what's this chart about? Well, it turns out, quite surprisingly, that 72% of containers in production live for less than 5 minutes. No one can suddenly go and connect to them and see what's running in them, because probably by the time they've done the bad thing they're going to do, they've disappeared again. So there's significant challenges for us, in addition, in the area of forensics. Many of you, I'm sure, will be very familiar with this comic. It's still a pretty good description of the world upon which we have built. There are some small projects with very fragile maintainer and security infrastructure, on top of which a lot of us actually depend. So fundamentally, what we've seen is kind of like the internetization of software, where the democratization of access, the ease of reuse, combined with a very poor trust infrastructure, has brought us to probably where the web found itself in the 2000s. So we have a lot to do. Where do we go from here? The vast majority of the enterprise software stack is now based on open source. Yet that progression of open source isn't uniform, and security solutions themselves are kind of notable in their lack of embrace of open source for the most part. And we're sort of in the throes of the beginning to solve for the problem in a variety of ways, from examining the software supply chain through to creating zero-trust execution environments. But open source has to be part of the solution. And so if it is, what solutions are there? Well, we can definitely get better at every layer of the stack. And it would take much longer than I have to talk to you just to kind of give you an overview of the initiatives at each layer. And this is certainly not an exhaustive categorization of the layers where work is being done. So this conference itself is going to be focusing on those cloud layers, the things around containerization and around runtime. But it's also important to focus out, understand the wider context that we're working in. I want to not ignore either the fact that security is, in addition, a social problem. And open source itself is fundamentally a social construct as well. Inside organizations, developers, don't get on that well, don't talk that well to their DevOps folks, their admins, their ops people, who also have very different concerns from the security teams. So even inside organizations, there are very different things at play. Developers want to ship code, create value, push stuff out quickly. Laziness and hubris are their chief advantages in life. They have very different priorities from folks in DevOps who clearly want to do things robustly. They want to keep the resource consumption low in their environments. They don't want problems. And that, too, is also at war with some of the incentives of the security team. So right now, if the problem is to be solved holistically, we also have a people problem going on. Now, I don't expect those particular incentives to change in a hurry, to be honest. So what are we going to do with the fact that these are all key personas in our security strategy, but we have to provide a solution to the current situation? Now, I think inevitably this means there has to be a degree of collaboration. And right now, within companies, within organizations, the degree of interoperation between platforms, and particularly the security aspects of these platforms for these different personas, is pretty poor. And so a collective approach to this problem is going to require, in addition to open source, it's also going to require common language, interoperation. And one component of this, clearly, is standards. If tools and platforms are to operate together, they have to do so in a common language. Even though there are different incentives, we're talking about some of the same problems, vulnerabilities, what's actually running, what's in our inventory. We have to solve this not just in a commercial manner, but also in a public manner and a regulatory manner. Now, just in case you think I'm here to say, well, let's solve this all with standards, I want to warn you there are dragons here. Again, this should be a very familiar cartoon to you. You think you're solving the world by creating a standard, and all that happens is you're adding one more standard to the stack. And so we have to be pragmatic. Standards have to live or die by the problems that they solve. And we as technologists and consumers have to be kind of wary a little bit of the wholesome glow and the hype train. I myself have come through about 3 or 4 of these waves now, from the web and HTML through XML and web services and how that was going to solve everything, Web 2.0, and now we have through all these things, and different standards and different technologies offer things. And inevitably we face the same problems that we faced in the generation before, and we reinterpret them in the light of the new technology, and things settle down. So, for instance, we think right now SBOMs, bill of materials, are a really good idea. And they are useful, but without enforcement, they're just paperwork. And they can introduce their own attack vectors. You may remember when the title tag in HTML meant something, where you got a title tag and you could believe it, before people started gaming that for search engine optimization and so on. And every time we have a metadata layer that we depend on, we have to ask, well, where could that go wrong? How do we enforce it? is it going to be useful in the long term? So it's not just standards. We're not without choices and problems in the open source tooling space. We're right now at this sort of Cambrian explosion of potential solutions and potential components that will make up the ultimate stack. And if you've taken a look at the CNCF landscape of projects recently, but it is impressive in its volume, but inscrutable and difficult to figure out what you actually should do and what you should build on top of it. So we're building as fast as we can. We're trying new and interesting ideas, but our track record is short. And we have sometimes very conflicting incentives. So to give you the good news, you know what? This isn't going to get any easier. Security just is a hard problem. And if we're to address this problem within the incentives of the personas that are involved, we're going to need our solutions to be pervasive. We need them to pervade the software stack, and we need them to be in the platforms that we operate software on. We need it in our clouds. We need it in our developer tools. And the need for cybersecurity solutions to be based on open source itself is even more important. Open source collaboration is the quickest way to reuse knowledge and share that and collaborate within industry and government. So I think in the same way that we've seen with other platforms, we're going to be dragging yesterday's security platforms forward. Initially with skepticism, then with excitement, and then with pragmatic rationalization. In the same way that the scale tech era has dragged the software development lifecycle forward in general. So I kind of want to leave you with these thoughts that the future of security is very necessarily open. In many fields, it's not novel to assert that open source is the future anymore. I think it's a little more so in the security field. So here's a quick manifesto. Firstly, we need collective intelligence. Security is a never-ending battle against expanding attacks and a variety of platforms. We need collaboration to bring together that expertise, apply more scrutiny, cover a broader range of use cases, cover proprietary than you can do through proprietary development. You don't need to ask anyone's permission to expand an open source solution to cover your platform. Open platforms, standards-based and open source, promote choice, they promote interoperation, they create the ability to create an ecosystem where all the surrounding support of training and services that you're going to need can exist. Open source is, of course, transparent, gives you the full visibility to introspect and even influence the development of software direction. If you're going to trust every node in your systems with a particular tool, you want assurance about its security, about its direction. And even if you don't have that ability to do it yourself, you can actually be reassured by the fact that the cloud scale of folks who do rely on this open source are putting in those resources to secure their platforms because the risk for them is so much higher. And finally, of course, modern platforms are being built on open source, and there is no way in which the security answer cannot be itself part of that platform and working in open source. And of course, it goes without saying that no one commercial interest should be allowed to dominate and own what actually is security for us. So, to sum up, Mark Andreessen famously said that quote about how software is eating the world, and this was, the basis of all these startups in the last decade or so. Well, what's happened is the internet has also eaten software, and we really can't wind that back anymore. So we're in a place where we need a corollary for what we used to know in networking as Pastel's law, which was, be conservative in what you do, be liberal in what you accept from others. Maybe for our time, the law goes something a little more like, be conservative in what you create and place little trust in what others give you. So I think this winds us up as a pretty good place to start focusing in on how we create platforms that are inherently secure and the role necessarily of zero trust. Thank you.